Hey, how about we continue our work here in Chapter 2 with Section 2.5 on transformations of functions. So what we want to do is work with vertical and horizontal shifts to graph some functions, and then also look at reflections and vertical stretches and shrinks to graph some of the functions we saw in the previous section. So let's recall some of the basic shapes. When I see, excuse me, when I see the absolute value, I know that its shape is a V shape. So the V shape just looks like this. And when I see the square root, I know the square root shape has this basic shape, arcing out to the right, starting here at 0, 0. Absolute value is centered at 0, 0, and then goes out as a V in either direction. Now let's use our calculator and see what happens if we graph these different versions of that parent function. So I'm going to pause it, take a second, and put these in my calculator. So to put a function in your calculator to graph, always go to y equals. And notice I've put in the first three, but let me put in the fourth one so you can see what I do or what I did. So I need a negative, so I'm going to use this little guy down there for the negative. I need an absolute value, so let me show you where to get that. If you hit Math and scooch over to the right once, you'll see at the very top under Num, ABS. There is your absolute value function, so press Enter. And what I want is a negative absolute value of x plus 1. So there's my x, there's my plus, there's my 1. Now remember, if the equal sign is highlighted, that means that's the function it's going to graph. So let me come over here and take the highlight off on that one. So now you'll see I'm only going to graph the absolute value of x minus 2, the first one here. And when I graph, I'm always going to go to Zoom 6 to put it in a standard viewing window. And what you'll notice is it's the V shape, but notice right there, it's not starting at 0, 0, it's starting at 0, negative 2. So the first one looks like this. And when I compare this red one to this blue one, what I notice is that it's going down, or it went down 2 units. Okay, so now let's look at the next one. So let me go to y equals. I'm going to arrow over and turn this guy off, and I'm going to go down and turn this guy on, and I'm going to graph him. Notice it's the same shape, the V shape for the absolute value, but it's not starting at 0, 0, it's starting at 0, 1, 2, 3, 4. So let's graph him. Oh, let me go with green. Okay, so right there is 0, 4. It's the same shape, but notice this one went up 4 units. All right, now let's look at the last two. So let me go back to y equals. Let's turn that one off, and let's turn this one on. We'll graph him. Same V shape, but notice it's been scooched over to the right 3 units. All right, so let's draw him. How about we go with purple? 1, 2, 3, right there. It's the same V shape, but it went to the right 3 units. And then finally, this last one, the negative absolute value of x plus 1. Let's compare him. turning him off, turning him on, and let's graph him. What happened this time? Well, it looks like it was moved to the left 1 unit, and then it's flipped over this x-axis. All right, let's draw him last. So what did we say? It went to the left 1 unit, and it was flipped over the x-axis. And then we did a reflection, basically, across the x-axis. So taking a look at the basic shape, so the absolute value shape was just that blue one. That was just the absolute value of x. So absolute value of x was the basic V shape. What happened when we subtracted 2 from the absolute value? It went down 2. When I added 4, it went up 4. When I subtracted 3 on the inside of the absolute value, it went right 3. And when I added 1 inside the absolute value, notice it went left 1. But then the negative in front caused it to reflect across the x-axis. All right, so now let's take a look at the square root shape, and let's see what happens to him. So I'm going to pause it and put those in my calculator. Okay, so I've placed those functions in my calculator. The square root of x is this arcing shape from the middle, goes to the right. And so let's graph the square root of x with a negative out front. Notice he reflects across that x-axis. So let's graph him. Oh gosh, red. All right, so that guy reflected across the x-axis. So the original is blue, the new one is red. So that's this guy right there. Okay, let's look at the next one. What happens to him? So let me go to y equals. Let me turn him off, and let me turn him on, and let's graph. Ha! The original blue goes in that direction, but this one now arcs out to the left. So when I compare them, I'll do this one in green. He looks like that. So the center is still 0, 0 for all of these, but this one is arcing out to the left. So there's been a reflection across the y-axis. That negative inside tells me I reflect across the y-axis. Let's check the next one out. Let's see what happens. So let me go to y equals, and I'm going to turn him off and turn him on. So here I have a 1/2 in front of the square root of x. And remember, the original is the blue one, so it's still arcing out to the right, but if you notice, it shrunk quite a bit. Actually, it's half the height. So that 1/2 in front of my square root of x causes that to have a vertical shrink. It's shrinking vertically. Okay, so let's graph him. Still at 0, 0, but it looks like that. So what we have is a vertical shrink. That's what that 1/2 in front does. Actually, what the 5 is going to do is it's going to give us a vertical stretch. I'm going to turn him off, turn him on. Okay, and let's graph him. See it? So square root of x would normally be right here, but with a 5 in front, I see it stretching vertically. So let me get that guy graphed on here. Let me go with a purple. All right. So now that guy does something like this. This guy, vertical stretch. Oops, what color was that 1/2? It was pink. So let me go to pink and keep everything color coded. That was this guy. So what we can do is we can take all of these properties that we saw and write them in general terms. So the observations that we saw above, let's write those in some general terms. Actually, I prefer this little guy to be up here. Okay. Ooh, why does it keep doing that? I want you up here. There we go. All right, so in general terms, if I take a function and add a constant to that, what I'm going to see is a shift up C units. If I take my function, subtract a number from it, what I'll see there is a shift down C units. If I add a constant to the inside of my function, like I had a number inside those absolute values, that's going to shift it. But here it's going to shift when it's a positive number inside, it's going to shift it to the left. C units. Notice when it's inside, if it's a positive, it's going in the opposite direction that you think. So positive C goes left. If I subtract a C on the inside, it's going to go right. C units. Now, if I put a number in front, like that 1/2 or the 5, 1/2 is between 0 and 1, and what we saw was a vertical shrink. If the number in front is a number bigger than 1, like the number 5, then we see a vertical stretch. And finally, the last two, if there is a negative in front of your function, we see a reflection. And it's going to reflect across the x-axis. And if that negative comes inside, like it did on the inside of that square root, we're going to reflect across the y-axis. So we need to know these properties. So when I see a function and I see a number inside or outside, added or subtracted or multiplied or a negative, I know exactly what's going to happen to that graph. So yeah, I want to know this information. Here is what I want you to do for the problems on this page here. I want you to look at the equation, do a quick draw of the basic shape. The x cubed has this sort of curvy shape. Then once you've drawn the basic shape, tell what happens to it. Like in this case, the -7 means it's going down 7. Here, the squaring has the basic shape of a parabola. The +3 on the outside means it's going up 3. The +5 on the insides means it's going left 5. And the negative out front means it's going to reflect across the x-axis. So I want you to take all of these, give that information for all of them based on our rules up here, based on our rules on what's happening, and then you can use your calculator to graph them, but I want you to describe what's going on. So pause it, do it, and then come back and check your work. So compare your work with what I have here. You can look at my description of vertical stretch, and so we see a thinner V shape. Here, we're reflecting across the x-axis because of the negative in front, and we're going left 5 because of the 5 inside, and we have that basic arcing shape. So it's left 5 reflected across the x-axis. Here, we reflect the x, then we reflect across the y-axis, and we're going to move it up 2. So your final shape should look like this, that arcing shape. Finally, x squared is a parabola, and that 1/4 causes us to have a vertical shrink, so we should see that parabola shape just a little bit wider. So I'll stop this video here and continue with the next one. Actually, no, let's just go ahead and finish this page up. Okay, so now we want to go backwards. Given the shape for f of x equal x squared, we're going to shift him 3 units to the right, 7 units down. What we want to do is create the equation. So we're given some general information about what happens to the graph. Let's see if we can construct an equation. So we're going to take x squared and bring him 3 units to the right. Well, that means I need a -3 on the inside. Remember, inside numbers go left or right. Now I want to take him 7 units down, so the outside numbers tell me up or down, and I'm going to put -7 because the outside numbers, when you shift up or down, go in the direction with respect to that sign. Okay, let's take x squared again, and we're going to shift him 2 units to the left, 9 units up, and reflect the x-axis. So 2 units to the left means I need a +2 on the inside. Remember, the inside numbers make him go left or right. 9 units up means I need a +9. And to reflect the x-axis, I need a negative in front. Let's do another one with x squared. I'm going to shift him 6 units to the left. Remember, left or right goes inside. And since I'm going left, I'm going to put a +6. 2 units to the left was a +2. 6 units to the left is a +6. I'm going to go 6 units down, so I need a -6. Oop, can't forget my square because that's my parent function. And I'm going to reflect it across the y-axis. This one's really weird, the way we would write that. So if I were going to reflect him across the y-axis, there needs to be a negative on the inside, so it would kind of look like that. That one's kind of weird, and I don't think you're going to see any of those actually in the homework. Actually, I don't even know if that's the way it is. But you know what? You're not going to see this one in the homework. So let's just forget it, but let me do it for you. I'm going to reflect across the x-axis. I had my parentheses wrong. I need a parenthesis, negative, parenthesis, x +6. And the whole thing would be squared, then a -6. This would be the correct version. This would not be, but you're not going to see those in the homework. Finally, we're going to go absolute value function, so that's my parent. We're going to take him 12 units up and reflect the x-axis. So to take the absolute value and move him 12 units up, we put a +12 on the end. And to reflect the x-axis, we put a negative outside. Okay, let's look at one last thing here, which is an application. So let's wrap up this section with this last application. The application gives us an equation for the number n in millions of households in the United States from 2000 to 2014. And this equation can approximate the number of households by n sub x is equal, n of x is equal to negative 0.023 times x minus 33.12 squared plus 131. And this model can be used from the values of t equals 0 to 14. That means this model only works from the year 2000 to the year 2014. Because t equals 0 corresponds to 2000. So that 0 means we're year 2000. That 14 means we're only looking up through 2014. So that's where this particular equation will apply. So the first thing we want to do is describe the transformation. Well, I know the square means it's a parabola, and the positive 131 on the end means that parabola is moved up 131 units. The negative 33.12 on the inside means it's moving to the right 33.12 units. So that tells me it's going up. This tells me it's going to the right. The negative in front means it's going to reflect across the x-axis. And the 0.023 means I have a vertical shrink. All of this information is important. That's part A. Describe the transformation. Now, let's use our graphing utility to graph this. So, what I've done under y equals is I typed in the equation. Let me make sure I got it typed in the correct way. Yes, it is correct. But I want to graph it on this domain, 2000 to 2014. So I need to go to my window, and I need to let my x-min be 0, so that's 2000. I need to let my x-max be 14, that's 2014. Then for my y values, I'm going to start it at 0. Then I'm going to stop it at 150. I was going to stop it at 131 because that's where the graph shifts up to, but I just made it go a little bit higher than 131. So I'm going to graph it with that window. As you can see, we've got a piece of a graph, not a whole parabola, just a piece of it from 2000 to 2014. Okay, so we graphed it, we described the transformations. Now let's find the average rate of change. And remember, the average rate of change is just the slope. So for part B, I want to find the average rate of change, which is the same thing as slope. And I'm going from 2000 to 2014. So when t is equal to 0, 2 t equal 14. You know how to find a slope. All we need are two ordered pairs. So I want to find the ordered pair that has a 0 in the first position and the ordered pair that has a 14 in the first position. So let's go to our calculator and let's go to the table. Notice at 0, I get 105.77. There's my ordered pair, 105.77. And at 14, let's just go on down. Come on, baby, keep going. Got it. At 14, it's 122.59. Average rate of change is the slope between 2 points. I now have my 2 points, so calculate the slope. y2 minus y1 over x2 minus x1. So 122.59 minus 105.77 over 14 minus 0. So find that slope. So the average rate of change from t equal to 0 to t equal 14, 2000 to 2014, is 1.20142. I mean, it goes on, but basically that's what you get. All right, so if you take a look at the graph, notice this graph has a very slow increase. So that's why we got a positive slope. Finally, we want to use this equation that basically only works from 2000 to 2014, but we want to use it to predict what might happen in 2022 and see if the number we get makes sense. So let's use that equation to find out what happens in 2022. I'm going to go to my calculator and I'm going to go back to my table and see what happens when the x value is 22. Just involves a little more scrolling. There we go. At 22, it's 128.16. So straight from the calculator, we get that value. And so we use the model to predict the number of households in 2022. Does the answer seem reasonable? Well, taking a look at for 2014, it was 122.59. And given that we had an upward slope, I would see a slight increase from 2014 to 2022. And a slight increase we see in 128.16. So I would say, yeah, that answer seems reasonable. So I will leave this. I'll stop the video, but as always, let me know if you have any questions.